For the first time ever, an asteroid or comet from another star has been caught hurtling through our solar system, astronomers announced late Thursday. Provisionally designated A2017U1, the object appears to be less than a half kilometer in diameter and is traveling at just over 40 kilometers per second, faster than humanity's speediest outbound space probes. Because this is the first object of its type to be found, there are as yet no official rules for naming it, and its discoverers have balked at suggesting anything besides interstellar. Whatever one might call it, though, it is presently racing away from the sun and has sparked a stampede of astronomers rushing to observe it before it fades entirely from view in the darkness of interstellar space. All we can say right now is this was something that was tossed out of another star system, says Karen Meach, an astronomer at the University of Hawaii. Meach is helping coordinate a global observation campaign, which presently includes nights on large telescopes in Chile and Hawaii, as well as 5 orbits of the Hubble Space Telescope. Everyone is trying to get time to look at this thing on big telescopes right now, urgently, within the next few days, she explains. Exactly what those telescopes might see is anyone's guess. Astronomers will first and foremost attempt to pin down the object's exact size based on its brightness, as well as its shape and spin rate based on how its brightness fluctuates. They will also seek to measure A2017U1's color, and perhaps even its spectrum, the subtler details of its emitted and absorbed light. Taken together, all that information could show what exactly A2017U1 is made of, whether it is mostly rock, or ice, for instance, and potentially reveal more about its history and origins, somewhere out there among the stars. Most likely, Meach says, the object is an outcast from another star system, a space rock flung out during the star's tempestuous youth when it was surrounded by freshly formed giant planets embedded in a disk of debris. One of those planets hefted its weight, and tossed this thing and a lot of other stuff around, she says. So now we have a piece of another planetary system flying by Earth, flying through our solar system, that we briefly have a chance to study. The same process is thought to have unfolded billions of years ago around our own star, when Jupiter and Saturn formed. Those giant worlds may have scattered debris all across our solar system, helping form the asteroid belt as well as the icy Kuiper belt, of which dwarf planet Pluto is the largest known member. Much of that scattered debris ended up even farther out, about a light-year from the sun, in a spherical shell of comets called the Oort cloud. The farthest flung debris probably escaped the solar system entirely and may be cruising through the void even now, bound for parts unknown. Going hyperbolic, A2017U1 was first discovered on October 19 by Rob Warwick, a postdoctoral researcher at the University of Hawaii. He found it, a faint, pale dot streaking across the sky, while reviewing images from the university's Pinstairs telescope, which searches for near-Earth objects and NEOs from the mountain in Haleakala. When I first saw the object in question, I immediately thought it was a NEO that had not been seen before, being quite close to the Earth, Warwick says. But then I started to look for additional detections from other nights, and when I found it in images from the night before, the data didn't make sense. Follow-up observations taken at Warwick's request by astronomer Marco Micheli, using a European Space Agency telescope in the Canary Islands, only deepened the mystery. Based on its estimated speed and direction of travel, the object appeared to be on a hyperbolic trajectory, moving out from the sun fast enough to escape our star's gravitational pull entirely. Barring the rare space probe launched from Earth, any massive object with enough speed to leave the solar system likely originated beyond its boundaries, too, because such speeds are difficult to build up solely through natural gravitational encounters with our sun and its planets. A further batch of observations gathered by Warwick's advisor, astronomer Richard Wainscoat, confirmed A2017U1's unprecedented motion. From there, the Pinstairs team began coordinating further studies of the object with the wider astronomy community, including researchers at NASA's Center for Near-Earth Object Studies (CNEOS) at the Jet Propulsion Laboratory in Pasadena, CALIF. This is the most extreme orbit I have ever seen, said CNEOS scientist Davide Farnocchia, who worked with others to trace A2017U1's path through the solar system. We can say with confidence that this object is on its way out of the solar system and not coming back. Dark objects, bright futures. Based on these analyses, A2017U1 came from the direction of the constellation Lyra, swooping in from high above the ecliptic plane in which the sun's planets orbit at a breathtaking 25 kilometers per second. According to calculations by Micheli, that trajectory placed it 25 times farther out than Pluto in the year 1837, and it crossed the orbit of Neptune in November of 2012 on its sunward plunge. pulled by our star's gravity. On September 9, A2017U1 approached within 40 million kilometers of the Sun, well within the orbit of Mercury, before being flung back up and out of the ecliptic plane in the direction of the constellation Pegasus at nearly 44 kilometers per second. On October 14 it passed less than 25 million kilometers from Earth, about 60 times the Earth-Moon distance. Astronomers could not see it, then, however, because its trajectory took it too close to the Sun as seen from our planet's skies. As its distance from the Sun increases and less sunlight strikes its surface, A2017U1's brightness will plummet. Already, Meech says, its glow is diminishing to the equivalent of one of Pluto's small moons as seen from Earth. By the end of next month it will be at the limit of what the world's largest ground-based telescopes would be able to discern in a 10-hour exposure. Much beyond that, even keener-eyed space-based observatories such as Hubble will struggle to see it. Maybe we had a window of a little over a week, maybe two, in which we could have discovered this thing by its brightness alone, Meech says. It was moving so fast, and registered so faintly in detectors, that Pinster's finding it at all seems to have been a matter of luck, or at least whatever happens when preparation meets opportunity. Imaging the entire firmament overhead night after night, the telescope is one of several ALSCI surveys already or imminently-ing the heavens. These facilities, most notably the Large Synoptic Survey Telescope LSST set to debut in 2020, promise to revolutionize the field of transient astronomy, the study not of steady shining stars and galaxies, but of the things that rapidly move and change, exploding stars, whirling asteroids and comets, and anything else that goes bump in the outer night. No one really knows yet how often interstellar interlopers like A2017U1 soar through our solar system, but observatories like Pinster's and the LSST could soon find out. This, to Warwick, is perhaps the most vital thing to learn. The most important response to the okay, so what question is, well, where do these things come from, and are there more, he says. There is still a lot we don't know about the solar system, and finding objects like this could help improve our understanding of how the Earth and our solar system first came to be.